Alright, g'day. Welcome to this quick lesson on gradient, how to construct gradient, and also what is gradient. Alright, well, what is gradient? Gradient's a geographic skill. We often use it when we're calculating a cross section, or we're looking at a cross section, but generally it's used when we're looking at a topographic map, a map that's got contours. What gradient is, I've just taken this from a textbook. It tells us the average, whoops, let me get the pen on. It tells us the average steepness of a slope. We generally express it as a fraction or a ratio, but we can express it in a written form as well. So you can see there it's been, that gradient there has been expressed as a ratio. We're always looking at giving the answer as, for every 1 metre in vertical rise, how far would we have to travel along the ground? Once again, with all geographic skills, try and remember, your answers should make sense in the real world. The way to work out gradient, many students have heard it before, basically is rise over run, looking at the vertical difference between your 2 points and over the horizontal distance. For those of you that have watched my vertical exaggeration and my cross-section videos, I'm going to be using the same map. It's a nice simple map, and I think because it's simple, it's easy to start to explain the process. You can see here's the cross-section, and I've already done the vertical exaggeration. For this one, what we're going to look at is the gradient from C to B. Now, what we know from the cross-section video is that point C on the river, it didn't quite get to 100 metres. It didn't drop to 100 metres. We said that it was about 125 metres. Point B, the top of Dome Hill, was over 600, but we didn't really have another reading, so we have an estimate, and we're going to say it's 625 metres. Those two heights are definitely required for working out gradient. And remembering here, I've estimated those. I've not been given those heights there. I've made estimations based on the contour lines and the general topography of the region. So, the gradient from point C to point B, the gradient, you can see I've written down the formula here, is rise over run. The rise is the difference in height from point C, which we said was 125, and point B at 625, over the run. The run is the horizontal distance. In order to do this, I need to use the horizontal scale again, and I get my ruler out, and the distance there is 7.5 centimetres, and I remember from the cross-section and from the vertical exaggeration when I did it earlier, that 1 centimetre on this map equals 400 metres. So the rise is 625 metres, the height of point B, minus 125 metres, which is the point of point C, and it's 7.5 centimetres times 400, which will give us this, 500 metres over 3 kilometres. This is always where I find students have or make mistakes when they're working out gradient, is that their units of measurement are not in the same, they're not in the same units, and this is always where invariably a student will make an error. So what we need to do now is convert one of them. You could convert the top, but I would suggest that you convert the kilometres to metres. So you can see here, that's what I've done. 3 kilometres here turns to 3,000 metres. Now, it's at this point here that we need to remember what we're trying to do. What we're trying to do is to say that, well, for the average steepness of the slope, and we need to get that to 1. At the moment, that's 500. And that's 3,000, but we need to get it to 1. In order to get to 1, we're going to divide that by itself and then do the same to the bottom, which will give us our... So you can see here, that's exactly what I've done, and that gives us an answer of 1 in 6, or if it was a ratio, 1 to 6, but basically what it means is that for every 6 metres, so for every 6 metres that we travel in a horizontal direction, we go up by 1 metre. Remembering that this is average steepness, and that when we're looking at a map, topography is going to vary greatly. Once again, and I've said it with a lot of the skills, your answer should make sense in the real world. Look at your map. If you get an answer that comes back as a decimal or doesn't quite seem right, then there's a chance you have made a mistake somewhere along the line. Your answers, the maps that we're looking are generally going to be real world maps, so your answer should make sense. Try and think about it that way. For every 1 metre I'm going up, how many metres do I go forward? Okay, hopefully that's helped you out with grading and explained what it is. Should help you out with your exams and any assessments coming up. All right, good luck with that. Bye.